So good day everyone. So I'm the next reporter and my report is all about the graph analysis. So I'm Reyes Canabin by the way. So so I will continue the report about the surface and subsurface runoff phenomenon. So my topic is we have a graph analysis characteristic, unit hydrograph theory, Stendemannius unit hydrograph, synthetic unit, and the hydrograph application. So first is what is hydrograph? So a hydrograph show the two graphs, a bar chart showing the rainfall. So usually from the storm, a line graph showing the discharge before and during the after the rain. So show the bar graph. So so basically the hydrograph show may its ways to affect the effect in the storm. So it's help to understand and patterns particular drainage basin and to predict the stop and to predict the flooding. So and such a flood to prevention measured. So so in the graph below, so the peak rainfall as the time is the highest flow. So the peak discharge and the time. So water higher reaches the higher flow. This there is a delay. So because take the time to the find the river. So it's called at lag time. So So there are several types of hydrograph which include so first one is a natural hydrograph, second is unit hydrograph, third dimensionless unit hydrograph, and the fourth is synthetic hydrograph, and the lastly is a dam bench hydrograph of special case and natural or synthetic. So first is natural hydrograph. So natural hydrograph is a natural hydrograph is the one recording, gauging, site and the fingerprint in the upstairs drainage areas response to rainfall. So in this figure, so one siya example, the natural hydrograph figure. So the next is the unit hydrograph. So a unit hydrograph is natural or synthetic. So hydrograph presenting 1 inch of runoff. So uniform from the watershed during the special time. So in other words, the area of undergraph is actually the volume of the 1 inch of a round runoff. So this is the figure of unit hydrograph. This one below. So next is dimensionless unit hydrograph. So dimensionless unit hydrograph is a genetic combination of any natural unit hydrographs combined of many natural hydrographs. So the coordinates Cabezas scale are ratio of the drainage respect to the peak discharge and the time relative and length. So the peak is respectively. So that is a figure. So in the figure is merong merong river discharge. So in the volume, the water raving is show the river's channel. So in this it is the total value to the water showing the through the channel. So it's measured the water to the water. So next is a synthetic hydrograph. So synthetic hydrograph is calculated the based on the watershed. So and the storm characteristics and SES soil, land use, the vegetative cover, size, slope, and time. So of of connection are the important watershed characteristic. So synthetic hydrograph are used to stimulate the hydrograph or engage the water watersheds. So the figure. So next is damp bench or hydrograph. Special case natural or synthetic. So so a damp bench hydrograph represent the sudden release of the water from the from the impoundment due to the bench followed by the drainage of the surveyor. So this is example of figure. So next is introduction of the unit hydrograph. So the unit hydrograph show the temporal change in the flow or discharge per unit runoff. So in otherwise, show the flow of steam will be affected over the time. So the additional one of the unit runoff, the unit hydrograph use useful tools to process the prediction impact to the precipitation and on the stream flow. So the role of the unit hydrograph is a prediction to process to provide and estimate the the stream flow that result from the given amount. So precipitation. So a unit hydrograph show that the temporal change of the flow or the per axis unit prediction runoff. So the type of hydrograph, first one is a unit hydrograph. So a unit hydrograph is defined as the graph of the storm runoff resulting of the insulated runoff of some unit duration. So so occurring uniformly over the entire area of the catchment, so produce a unit volume. So it has 1 cm of runoff. So step to create hydrograph. So first is the select from the record is isolate single peak and instant storm, so which occurring uniformly over the catchment to have produced flood hydrograph which applicable so round off. So it's 1 cm, say 8 to 16 cm. So second is select the flood hydrograph which resulting from the unit chosen by step 1 above. So next is separate the base flow from the total runoff by the will know base flow separation of procedure. So next, uh, from the coordinates of the of the total runoff hydrograph, so it's regular to intervals deduct by the corresponding coordinates of base flow to obtain the coordinates. So next is divide the volume of direct runoff by the area and the drainage basin to obtain the net precipitation dip over the basin. So and the next is divide each of the coordinates of direct rainfall by the net precipitation dip to obtain the coordinates of the unit of the hydrograph. So lastly, plot the coordinates of the unit hydrograph against by the time since the beginning. So direct runoff, this will give the unit hydrograph the basin and to duration of the unit storm. So proceeding the flood hydrograph selected by step 1. So elements of the hydrograph. So the elements of the elements are certain unit hydrograph are date. So first one is base with or P. So this the period of direct surface runoff due to the unit storm of the unit hydrograph called time base or the base width. So next is unit storm. So the unit storm of unit duration of the unit hydrograph regardless it is uh, intensity. So the third one, unit period. So the time duration of the unit storm, duration of the unit, so hydrograph. And the fourth, lag time or LT. So the time of the certain of result storm to the peak discharge, the corresponding unit of hydrograph. And the fifth is precision or precision time, so the duration of the direct surface unit after the end and access or the rainfall. Next is proposition of the unit hydrograph. So first one is the same runoff duration. So for the total unit storm of the direct entities, the predict surface or runoff, so unit base base width or the base period is approximately the same taught by the reduce the different turn of volumes. So next, proportional coordinates. So for the unit term of difference entities, the coordinates of the hydrograph or any given time and are they are proposition of the as rainfall eccentricities. So the third is principle of superposition. So it's there to continuous storm and are insulated storm of uniformly intensity net rain. So they are maybe divided by the unit storm. So a hydrograph of a rainfall and storm and the coordinates added with the approximately time the lag get the combined hydrograph. So the fourth one is same distribution percentage. In the total period of surface run of time base or a base width, so it's divided to equal the time intervals and percentage to surface run up of course. So during the period, so with the same with the same of well of all unit storm are different intensities. So next is the the instantaneous unit hydrograph. So the hydrograph study using the instantaneous unit hydrograph provide a good approach by hydrologic research since the storm duration of effect rainfall. So in the close to the duration caused by the instantaneous bus of rainfall. So using the instantaneous unit hydrograph is also to analytic to magnitude the time and the peak equal to maximum flood. So we have example to make a hydrograph. So in this example, so the coordinate the coordinates of 6R unit hydrograph are given. So a storm has has successive 6 hours intervals of runoff. So magnitude of 3 and 5 and 4 and so perfectly assuming the infiltration losses of 0.2 cm per hour and the uniform base flow of 30 meter cube per second. So determine the resulting hydrograph and graph X. So kabalo man tanong na ang given dere is kaning time bar or kaning UH uh UHO. So UHO means direct. So direct. So so to solve this, so 0.2 na meter per hour ay cm per hour. So times sa 6 hours na given, so equals 0.2 times 6 equals 1.2. So ang katong 1.2 mao to atong first interval. So in the second interval, so 3 cm 3 cm 3 cm minus 1.2 so equals 1.8. So mo to ang second interval. So pagkuha sa third pagkuha sa third interval, so 2 250 so 250 so 250 times 1.8, so 450, and second is 600 times 1.8, so 1,800. So on and ipadayon na siya and sa third is 250 times 3.8, 950. So next is pero dapat sa ano na siya sa second interval na siya sa magpadayon. So 600 times 3.8 280. So ning ano lang siya padayon lang siya sa kaning sa i-times na siya i-times din. Pagkuha sa DRH is i-add lang siya. I-add lang i-add lang ang 400, 450 plus 0 and 1080 plus 950. So, 2030. So, i-add na siya, i-add. Tapos ang kaning BFO, so given na siya, muna siya katong 30% meter cube per second. So, ang pag-graph ani, so, pag-graph, ito na yan. So, so kaning i-input lang to no, kung unsay value dito. So, i-point lang nato. So, kanang light blue, so mauna siya katong so direct hydrograph. So, kanang red, so mao to ang katong OH katong ganina. So, kanang black, so mao tong katong 3 cm nato, kanang medyo dark. So, next is kanang kuan. Ang violet kay mao to ang 4 cm. And the pink is mao tong 5 cm. So, ako lang. Thank you.